Hello everyone. In our previous lecture, we have seen about what is CART algorithm and its working. Now let us discuss this algorithm with an example. Consider the weather dataset as an example for understanding the CART algorithm. In this dataset, we have totally 14 number of instances where the target is to predict whether to play golf or not based on the weather conditions. The weather conditions, outlook, temperature, humidity and wind are the features of the data. Now let us apply the algorithm for each of these features. First, consider the outlook feature. It can take three values as per the table, that is sunny, overcast and rain. Let's summarize the final decision for each of these values for outlook feature, which is given here. So we have the column outlook feature, the decision yes or no columns and total number of instances. So if we consider sunny outlook, the total number of instances of S is 2. That is, we can see here the 9th instance is S and the 11th instance is S. And for no, it is 3 for sunny. That is the row number 1, row number 2 and row number 8. So total instances is 5. Similarly, for overcast, number of S is 4 and no is 0 and total instances is 4. For rainfall, it is 3 for S, 2 for no and total is 5. So you can verify this with this table. Next, let us apply the Gini index for the outlook feature. Gini index is a metric used for classification tasks in CART. Our example is related to classification task because it predicts whether to play golf or not based on the weather conditions. So the decision is either yes or no. This Gini index stores sum of squared probabilities of each class. So we can formulate it as illustrated here. Gini is equal to 1 minus summation of pi whole square for I is equal to 1 to number of classes. Here pi indicates the proportion of items which belongs to the class label I. Now let us consider the instances of the outlook feature which we have framed in the previous slide. We have to calculate the Gini index for each category, that is sunny, overcast and rainfall. So Gini index of outlook equal to sunny is equal to 1 minus, we have to apply through the formula. So 1 minus pi whole square, that is the number of items which belongs to the class label I. So here we have two class labels, yes or no. So 2 instances for S divided by total number of instances 5. So we have to subtract the number of no instances from the S instance. So minus 3 divided by total number of instances is 5 whole square. So that is equal to 0.48. Next we have to find the Gini index for outlook is equal to overcast. So here we have to consider 1 minus S instances 4 divided by total number of instances 4 whole square minus for no it is 0 by 4 whole square. So the answer is 0 for overcast. Next we have to consider for rainfall. So Gini index of outlook equal to rainfall is equal to 1 minus 3 divided by number of instances 5 whole square minus for no it is 2 divided by 5 whole square. So the answer is 0.48. Now let us calculate the weighted sum of Gini indexes for the outlook feature. So Gini of outlook will be the total number of instances for sunny is 5 and the total available instances in our original data set is 14. So 5 divided by 14 into the Gini index for outlook equal to sunny is 0.48. So that has to be multiplied. Plus similarly we have to do it for overcast and rainfall. So for overcast the total number of instances here for outlook feature is 4 divided by the number of instances in the data set is 14. So into the answer for Gini index of outlook equal to overcast is 0. Similarly for rainfall it is 5 divided by 14 into 0.48. So the value is 0.342. So thus the Gini index for outlook feature is 0.342. Similarly, let us consider the next feature temperature and compute the Gini index for this. So the temperature takes three values from the original table, that is hot, cold and mild. So let us summarize the final decision of the temperature feature. So similar to Outlook feature, we have to calculate the number of S instances and no instances from the original table. So for temperature feature, for hot we have 2 instances of S and 2 instances of no, and totally we have 4 instances. And for cool we have 3 instances of S, 1 no instance, and totally 4 instances for cool. And for mild 4 instances of yes, 2 instances of no, and totally 6 instances. So this we can verify it with the original table. Now let us calculate the Gini index for temperature is equal to hot. So if we apply to the formula, it is 1 minus number of S instances is 2 divided by total number of instances 4 whole square, minus for no it is 2 by 4 whole square, and the value is 0.5. So next for cool it is 1 minus 3 divided by 4 whole square minus 1 divided by 4 whole square, it is 0.375. For mild it is 1 minus 4 divided by 6 whole square minus 2 divided by 6 whole square, it is 0.445. So next we have to find the weighted sum of Gini index for the temperature. So the weighted sum is for hot it is total number of instances is 4 divided by the original number of instances in the table is 14. So 4 by 14 into, for hot it is 0.5. The Gini index is 0.5 plus next for cool it is 4 by 14 into the calculated value is 0.375 plus for mild the total number of instances 6 divided by 14 into the value calculated is 0.445. So we have the final value as 0.439 for temperature. Next we have to consider the feature humidity. So it is a binary class feature. It takes two values, that is high and normal. We can verify it with the original table. And for humidity we have 3 instances of yes for high and 4 instances of no for high, and totally we have 7. And for normal we have 6 instances of yes and 1 instances of no. So the total number of instances for humidity according to normal category is 7. So now let us find the Gini index for high and normal. So Gini of humidity is equal to high is 1 minus the number of S instances is 3 divided by total number of instances 7 whole square, minus for no it is 4 by 7 whole square, and the value is 0.489. Similarly for normal it is 1 minus for S it is 6 by 7 and for no it is 1 by 7, so it is 0.244. Next let us find the weighted sum. So weighted sum for humidity is 7 divided by 14, that is for high it is 7 divided by total number of instances 14 into this value 0.489 plus for this also 7 divided by 14 into 0.244. So the value is 0.367 for Gini of humidity. Now let us consider the wind feature. It is also a binary class feature. It takes two values, weak and strong, which is there in the original table. So for wind we have 6 number of S instances for weak and 2 for no, and totally we have 8 weak instances for wind. And for strong category we have 3 instances of S, 3 instances of no, and total number of instances is 6. So now we have to calculate the Gini of wind is equal to weak. It is 1 minus total number of instances for S is 6 divided by 8 whole square, minus for no it is 2 by 8. So the answer is 0.375. Next for strong it is 1 minus for S instance it is 3 by 6 whole square, and for no also it is 3 by 6 whole square. So the answer is 0.5. Next we have to find the weighted sum. So the weighted sum is for weak it is 8 total number of instances divided by the original table contains 14 instances. So 8 by 14 into for weak it is 0.375 plus we have to add the values of strong, that is 6 is the total number of instance of wind for strong divided by 14 into 0.5. So the answer is 0.428. So we have calculated the Gini index for all the features. Now let us see which feature forms the root node. The final decision of all the feature with its Gini index is given here. For outlook it is 0.342, for temperature it is 0.439, for humidity it is 0.367 and for wind it is 0.428. Among these features, the winner is the outlook feature because it is having the lowest value 0.342. So let us put the outlook decision at the top of the tree. So it is having three values: sunny, overcast and rain. So in this we can see that the sub data set overcast leaf has only yes decisions. So here we can see that yes as well as no. Here also we have yes as well as no. But here we have only yes decision. So this means that the overcast leaf is over. So we can stop for overcast here. So in this diagram we can see that the overcast leaf node is labeled as yes since it contained only yes for all the values in the data set. So let us apply the same principles for other sub data sets in the forthcoming steps. So for outlook feature we have only two remaining sub data sets, that is sunny data set and rainy data set. First let us focus on the sub data set for sunny outlook. We need to find the Gini index scores for temperature, humidity and wind features respectively for the sunny outlook dataset. So this is the sunny outlook dataset. Here we have totally 5 instances for sunny outlook. Next let us consider the temperature feature for sunny outlook and find the Gini index for it. According to the original dataset, temperature had three values, that is hot, cool and mild. As mentioned in our original dataset, it has 0 instances of yes and 2 instances of no and totally 2 instances for hot. And for cool, we had 1 instance of yes and 0 instance of no and totally it is 1. For mild, we had 1 yes and 1 no and totally it is 2. Now let us find the Gini index for each of these values. So for hot, the Gini index is 1 minus the total number of S instances is 0 divided by total number of instances of hot, that is 0 by 2 whole square, minus for no it is 2 by 2 whole square and the answer is 0. Next for cool it is 1 minus, for S it is 1 by 1 whole square and for no it is 0 by 1 whole square and the answer is 0. Next for mild it is 1 minus 1 by 2 whole square for S and 1 by 2 whole square for no and the answer is 0.5. Now let us find the weighted sum. So the weighted sum of Gini of outlook equal to sunny and temperature is 2 by 5 into 0. So here 2 is the total number of instances for hot and 5 is the number of sunny outlook instances. So into the hot value calculated is 0. So plus next we have 1 for total number of instances of cool. So 1 divided by total number of sunny outlook instances, that is 5, into the value calculated is 0 for cool. Plus for mild it is 2 divided by 5 into the calculated value is 0.5. So the weighted sum is 0.2. Next let us consider the humidity feature and find the Gini index of it for sunny outlook. So as per the original table, for humidity we have two values, that is high and normal. The total number of instances for high is 3 and number of S instances is 0, no instances is 3. For normal the total number of instances is 2, for S it is 2 and for no it is 0. So let us find the Gini index for this. So Gini of outlook equal to sunny and humidity is equal to high is equal to 1 minus the number of S instances is 0 divided by total number of instances it is 3 whole square, minus for no it is 3 by 3 whole square and the final value is 0. Next for normal it is 1 minus 2 by 2 whole square minus 0 by 2 whole square, it is 0. So we have to find the weighted sum. So Gini of outlook equal to sunny and humidity is equal to the total number of instances for high is 3 divided by number of instances for sunny outlook is 5. So 3 by 5 into the Gini of humidity is equal to I is 0. So multiplied by 0 plus for normal the total number of instances is 2 divided by number of instances of sunny outlook is 5 into the value for normal is 0 here. So final value is 0. Next let us consider the feature wind and find the Gini index for a sunny outlook. So for wind, we know that we have two values, weak and strong, as per the original table. So the total number of instances for weak is 3, number of S instances is 1, and number of no instances is 2. And for strong, it is total number of instances is 2, for S it is 1, and for no it is 1. Now let us find the Gini index similarly. So Gini of outlook equal to sunny and wind equal to weak is equal to 1 minus for weak it is for S 1 by 3 whole square minus for no it is 2 by 3 whole square, and the answer is 0.266. For strong it is 1 minus, for S it is 1 by 2 whole square, for no it is 1 by 2 whole square. So and the final value is 0.2, and the weighted sum is we have to consider the total number of instances for week, that is 3 divided by total number of instances of sunny outlook, it is 5, into the Gini index for week, that is 0.266, plus for strong it is 2 divided by 5 into the value calculated is 0.2, and the value for weighted sum is 0.466. So now let us see the final decision for sunny outlook. So we have calculated the Gini index scores for features when outlook is sunny. So for temperature the Gini index is 0.2, for humidity it is 0, and for wind it is 0.466. So the winner is humidity because it is having the lowest value 0. So we can put the humidity check at the extension of the sunny outlook as shown in this diagram. And in this diagram we can note that the decision is always no for high humidity and sunny outlook. Similarly, the decision will always be yes for normal humidity and sunny outlook. So these two branches are over, so it can be labeled no and yes respectively. So as mentioned in our previous slide, for sunny outlook, high humidity is labeled as no and normal humidity is labeled as yes respectively. The overcast node is already labeled as yes. So next we have to consider the sub data set rain. So the rain data set is also having totally 5 instances. So next let us consider the temperature feature for rainy outlook and find the Gini index for it. So as per the original table, we know that for the temperature feature we have two values, that is cool and mild, and the total number of instances for cool is 2, number of S instances is 1, and number of no instances is 1. For mild the total number of instances is 3, number of S is 2, and number of no is 1. So let us find the Gini index for this. So Gini of outlook equal to rain and temperature is equal to cool is equal to 1 minus the number of S instances is 1 divided by total number of instances is 2 whole square minus for no it is 1 by 2 whole square, and the answer is 0.5. And for mild we have to consider the number of S instances, that is 1 minus 2 by total number of instances is 3 whole square minus for no it is 1 by 3 whole square, and the answer is 0.444. Let us find the weighted sum. So weighted sum is for cool it is 2 total number of instances divided by the number of rainy outlook instances is 5. So you can refer the table into the value calculated for cool is 0.5 plus for mild it is 3 total number of instances divided by total number of rainy outlook instances is 5 into the value for mild is 0.444 and the final value is 0.466. So which is the weighted sum for Gini of outlook is equal to rain and temp. Next let us consider the humidity feature for rainy outlook and find the Gini index. For humidity feature we have two values, that is high and normal. The total number of instances is 2 and number of S is 1 and number of no is 1. For normal the total number of instances is 3, for S it is 2 and for no it is 1. So now we will calculate the Gini index for each. So Gini of outlook equal to rain and humidity is equal to high is equal to 1 minus for S it is 1 divided by total number of instances which is 2. So 1 by 2 whole square minus for no it is 1 by 2 whole square. So answer is 0.5. Similarly for normal it is 1 minus, for S it is 2 by 3 whole square, for no it is 1 by 3 whole square, and the answer is 0.444. So weighted sum is for high the total number of instances is 2 divided by total number of rainy outlook instances is 5 into for high it is 0.5 and plus for normal it is 3 by 5 into the Gini value for normal is 0.444. So the final value is 0.466. Now let us consider the last feature, wind, for rain outlook and find the Gini index for it. So for wind, we know that as per our table we have two values, weak and strong. The total number of instances for weak is 3 and for yes it is 3 and for no it is 0. For strong, the total number of instances is 2, for yes it is 0 and for no it is 2. So let us find the Gini index now. So Gini of outlook equal to rain and wind equal to weak is equal to 1 minus 3 divided by total number of instances, that is 3 by 3 whole square, minus for no it is 0 by 3 whole square and the answer is 0. Similarly for strong it is 1 minus, for yes it is 0 by 2 whole square, minus for no it is 2 by 2 whole square and the answer is 0. So the weighted sum is equal to 3 by 5, that is for week the total number of instances is 3 divided by number of rainy outlook instances is 5 and for Gini index the value for week is 0 plus for strong it is 2 divided by 5 into the value calculated is 0 and the final value is 0. So let us see the final decision for rainy outlook. So for the feature temperature it is 0.466 and for humidity also it is 0.466 and the wind it is 0. So the winner is wind feature for rainy outlook because it is having the least value. Now since wind is the winner, let us put the wind feature for rain outlook branch and monitor the new sub data sets. So the new sub data sets are weak and strong under the wind. But as seen, the decision is always yes when the wind is weak and the decision is always no if the wind is strong. So this means that this branch is also over. So this is our final decision trees with appropriate leaf nodes which is labeled either yes or no. So thus we have seen the construction of decision tree for classification task using CART algorithm. Thank you.